Bet, 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 bet.
Like Kitty's on the playground, mama was coming times to be like Shot
Let me get my examples together. So this is the second video today. I make sure I'm talking loud. Can you hear me? No. So this will be covering systems of equations by using substitution and elimination. We're gonna do substitution first because that's the one we hate, and why not get that way. Okay, so here's my system of equations, right? When we're using substitution, what we want to do is plug one of these equations into the other and solve for the other variable. So what I want you to always do and look and see, is there one that's easier to solve or is already solved for a variable? So if I step back and I look at this, I want to see which one is already solved for whatever variable. It does not matter, whatever variable. The one I see is y. Do I have, and when I say already solved, I'm saying is one of the variables by itself already. The pink already has the variables by itself. So it's telling me that y is not just y no more. Y is not y. Y is 6x plus 11. So what I'm going to do is take that 6x minus 11, my bad, and plug it into the other one. This is my song, low key. Help me. Take the pink equation and plug it into the blue equation. Let me show you how that looks. Okay, so that's what I mean on plugging in. So I have y right here, but now from this equation I know that y is 6x minus 11. So I plug in 6x minus 11 for y. Okay, and then I just solve like regular. Okay, so after solving, I figured out that x equals 2. I am not done because I'm supposed to have x and y, right? Use the easiest equation you got to plug in and solve. The easiest equation is this one because it's already solved for y. I don't have to move nothing around. All I got to do is plug in the 2. So I take my pink equation and it says y equals 6 times x, and x is 2 now, minus 11, and solve. Y equals 1. See? How long has it been zoomed in like that? Alright, so look at it and see which one possibly already has the variable solved for. Pink or blue? Blue. Blue is already solved for y. So I'm going to plug in x minus 1 in for y because now y is no longer just y. Y is x minus 1. So I'm going to take my pink equation, and when it's time to write y, I don't write y, I write x minus 1 and plug that in. And then I solve. Remember right here, I cannot have a negative variable, so I have to flip both the signs. Okay? Now I have to take this x equals 4 and put it into the other equation. So my other equation says y is equal to x minus 1. So I plug in y is equal to x minus 1. Y equals 3. Okay? Your answer is 4, 3. See? It's not hard. So this one's a little different. So if I'm looking at this set of equations and I want to find something that's already solved for a variable, we ain't got one. So we solve whichever one is easiest. Now, me looking at it, I'm looking and saying, okay, it's probably easiest for me to solve for y in both of them. Now, if I solve for y in the blue one, I got to change the signs because that's a negative y. But if I solve for y in the pink one, it's a positive y. We straight make one move and we good. So I have to solve the pink one first before I can plug it in for something. We're still making a mistake when we combining 6 and 4. No. 6 does not have an x, so you can't combine them. Now I'm ready to plug in. So now I know that y is 6 plus 4x. So I'll take my other equation and plug it in. And then I solve. Now what I don't want us to forget is that when we have a negative outside of parentheses, you distribute that negative just like you would distribute a negative 1, okay? So now I know that x equals -3. I'm going to take this. Now, what you can do is you can plug it into 3 equations. You can plug it into this one right here. You can plug it into this one, or you can plug it into this one. Okay? If I was you, I would use the easiest one. The easiest one is always the ones that's already solved for the variable that you're looking for. I'm looking for y, so I want to use the equation that's already solved for y, so I'm going to use this one. Okay? Y equals 6 plus 4 times -3. And then I solve just like regular. Bam. So my answer, okay? So if I have these two, remember I want to look for the one that's easiest to solve. The easiest one to solve is the blue one, so I'm going to solve that one first. And I want to solve for x, because x already by itself. I just got to move 2y. So I add 2y on both sides. X equals 11 plus 2y. Okay? Bam. So I'm going to plug this x in up here for x, because x is no longer just x. X is 11 plus 2y. So I take my other equation. Alright, so I got y equals -4. I am not done because I don't have x. But I do know that x equals 11 plus 2 times y. So I'm going to take that blue equation, and instead of y, I'm going to plug in -4. So it's almost like you're finding new information each time, and you're plugging in that new information. So my answer is 3, -4. Okay? Just like that, y'all. So when we're dealing with elimination, elimination is just another method. Do you have to use elimination? No. Once you learn both of them, if it makes more sense to you to use substitution, baby, I don't care how many variables we can eliminate. Use substitution because that's what works for you. But elimination is another method. Will you always be able to use elimination? Not all the time. Not all the time. But elimination will be adding. You're either adding or subtracting. Start with this. So I'm starting with this equation. Now when you're dealing with elimination, I want you to ask yourself, is there anything that has the same numbers? Does it look like it can cancel out? Like whatever. First of all, if I'm looking at y's, y's don't have the same numbers. So I know I'm not really paying too much attention right there. But the x's, they have not only the same number, but opposite signs. So 4 and -4. Now when we have a regular equation and we have opposite signs, we cancel them out, right? That's what we want to do with elimination. We want to cancel out one of the variables first, then solve for the next one, then plug in to get it. So if I want to cancel out 4 and -4, if I say 4 minus -4, 4 minus -4 gives me 8. So I know, that's how I know I'm not going to subtract right here. But if I say 4 plus -4, that will give me 0. So I want to add these two equations together. Okay? So when I say 4 plus -4, that cancels, right? When I say 8 plus 2 or 8y plus 2y, I get 10y. When I say 20 plus -30, I get -10. Right? Now all I got to do is divide by 10, and y equals -1. Okay, so I got y. Now you can plug into either one of these equations up here to get x. Either one, it does not matter, because this y is the same as this y, it's going to be the same. So let's say I want to use the top one. So plug in -1 for y, and then I solve for x. X equals 7. Okay? So my answer, 7, -1. Alright? So that's pretty easy, right? Cancel one out, find the other one, bam. Let's try another one. So now let's look at it. Do I have any variables that have the same number beside it? Yes, my y's. Now I need to decide, am I adding or am I subtracting? How do you decide that? Test and see. So I know I'm going to cancel out these 9's. Now if I add -9 plus -9, I get -18. So adding not getting me where I want to go. But if I say -9 minus -9, I get 0. So I know I want to subtract for this particular problem. Okay? When I say -2 minus -4, that gives me 2x. And then when I say -9 minus -9, that cancels out. And when I say -25 minus -23, I get -2. And now I'm ready to divide. So I'll say 2x equals -1. Bam, I got x. Now I take x and I plug it into either one of my equations. It does not matter which equation you pick. It don't matter. I want to pick the top one because I like pink. But I only like writing in pink. That's the crazy part. I do not like wearing pink, but I like writing in pink. I don't know. But yeah, I'm going to replace x. Okay. So my answer is -1, 3. All right, so look at this one. Now, if I'm using the methods I've been using, I'm looking for an equation that's already solved for a variable. I don't have that. Now, I know first thing in your head is, let's just go to substitution. If you want to do that on your own time, baby, do that. But there is a way. So if you look and you see numbers that on the same variable, number one. So if you look and see at the x's, or do they have common multiples? That's what you're looking for, multiples. Yes, because 5 and 10 are common multiples. If I multiply 5 times 2, I get 10, right? Right. So that's what I want to do. I want to multiply this equation by 2 so I can change that 5 to a 10. Because it would just make my day to have a 10. Okay? And I distribute to everything. So you got to make sure you're not just distributing to what's on the left side of the equal sign. All of it. So this equation turns into 10x plus 2y equals 18. And now I'll bring my other one over. So now I'm dealing with something a little bit simpler than I had. Bam. So this one I'm dealing with now. Now I can do my regular. So I'm going to ask myself, I know I'm dealing with the 10s because they're the only ones with the same thing. If I say 10 plus 10, I get what? 20. But if I say 10 minus 10, I get 0. I want to do whatever's going to give me 0. So I'm going to subtract both of these equations. So 10 minus 10 cancels. 2 minus -7, that's 9y. And 18 minus -18 is 36. And then I divide 4. Wait a minute. No, never mind. Not done though, because I need to plug in somewhere. Either one does not matter which one you plug it into. Let's do the blue because I did pink last time. So 10x minus 7 times y, which is 4. Solve. Okay, bam. So my answer is 1, 4. See, it's not hard, dude. It's not hard, little dude. This that old. It's good being you. So if I'm looking at this, I want to look for my common multiples, and I want to see if I can easily change something by common multiples. What has a common multiple, Miss Davis? Definitely the y's, because 3 and 9 are common multiples. I want to change that 3 into a 9. How do I do that? I multiply by 3. Okay, so my new equation is 3x minus 9y equals negative 18. So let me scoot my life over. After I've done all my elimination tricks, this is what I end up with. Now I need to figure out what am I going to do. Am I going to add or am I going to subtract? So I know that what has the same numbers is the y. So I know I'm working with the y's. So if I say 9 minus negative 9, that gives me 18. So I know I'm not subtracting. I gotta be adding. Gotta be adding. And then I just go through and add. So negative 4 plus 3 is negative x. Negative 9 plus positive 9 plus negative 9 cancels. 9 plus negative 18, negative 9. I cannot have a negative x, so I have to change my variable. X equals 9. Change my sign. Okay? And now I take that and plug it into either one of the equations. It does not matter which one you plug it into. Do not waste your time trying to figure out which one should I plug it into. Whatever floats your boat, really. Okay, and there we go. There it is. 9, 5. That's my answer. All right. So I think that concludes the systems of equations. And now that just did something for my soul. Next video will be on the Unit 3 study guide. Cause we finally at that Unit 3 test. Couldn't got to Marty. Let me tell you something. It took us 10,000 years to get to that test. And I ain't exaggerating. I ain't exaggerating at all. But yeah, see you next video.
I can't believe